Hi. Today we're going to talk about multimeters for those of you who are interested in hardware. If you are not very versed in these things, maybe this will be too much for you, but let's see. I hope most of you will get basic info on this topic, what multimeters are, how to use them, and what to do with them. Hope you'll find it useful. So, what are the multimeters? These are the devices that measure some basic electrical values, like voltage, like current, and resistance. For every of those values, you have to use a specific instrument: voltmeter for voltage, ampere meter for current, ohm meter for resistance. But some clever guy thought, okay, I can put all these things into one thing and call it a multimeter and measure everything I need with just one device. And later they added a bunch of other useful or less useful stuff to it, and they got today modern multimeters. There are three types of multimeters today: old analogs with scales, digital manual ranging, and digital auto ranging. We'll see what's that. This is typical analog multimeter. You may have seen it before. You have scale and needle that shows the value when you measure. This is typical modern auto ranging multimeter. And this is what we're going to do today, manual ranging. If you learn to use manual ranging multimeter, you'll know pretty much everything you ever need to know about how to use multimeter in your everyday use. So, these manual ranging multimeters have so-called ranges that you have to manually change. First, we have different functions on this dial. You have function to measure DC voltages, AC voltages, that's direct current and alternating current. Also DC and AC currents, resistance, transistor gain, frequency, continuity and diode test, and capacitance. Bunch of different stuff, and everything is controlled from here. By turning this knob, you decide what to measure and on what range. First, we'll talk something that is most useful to most of you. It's DC voltage. You have 5 different ranges: 200 millivolts, 2 volts, 20 volts, 200 volts, and 1000 volts. We'll see why we need them. When you measure something, you don't know how large is the value you're going to measure. Always start from the highest range, in this case 1000 volts. If you are sure that value is somewhere in some specific region, you can start from there. So let's measure 9-volt battery. Because we know that 9-volt battery is somewhere around less than 20 volts, we can start there, but for this purpose, let's start from the highest range. So we connected probes to our battery. We changed the range to 1000 volts, and we are measuring now voltage, DC voltage, and it shows 9 volts. Okay, that's nice. But let's take some more precise measurement, and let's give it a notch down to smaller range. Now we can see that we got one decimal point. It says 9 volts, 0.4. That's more precise. If we lower the range, we'll get more precise measurement. Now we see that it's 9.39 volts. So that's the voltage of new unused battery. And this is the best possible reading we can get. If we go on lower ranges, we'll get this one. One is indication that you are over range, that a multimeter can't measure such high voltage. Why? Because he has a range of 2 and 200 millivolts, and that's hard to measure 9 volts with. So you must go back to 20 volts and measure it. So what we are changing here? We are changing accuracy and resolution. But I'll say something more about that. If we look at specifications of modern multimeters, first you'll see how many bits it has. This multimeter we are showing now, the yellow one, has 3.5 bits. What's that? That means that it can show 3 whole bits or digits, and first digit can only be 0 or 1. We call that 3.5 bits or digits. Some more advanced multimeters have more bits, and they can show more precise values. So you can get 3.5 bits, 3 and 4, 4.5, 5.5, 6.5 bits, and you can measure more precise with more bits. And that's not very useful to most of you because that's only for laboratories, and for everyday use that's too much. 3.5 bits is what you need. So we can have 1,999 counts in 3.5 bits. So the smallest value it can show, that's called resolution. And the smallest value depends on range that we are using. So if we're measuring at 200 millivolts, it will, that's the first case, we can show 1.999. So the smallest bit here is 0.1 millivolt, and that's our resolution on this range. As we lift the range, the resolution changes. So at 2 volts, resolution is 1 millivolt, and etc. Why is that important? Well, it's normal. At 1000 volts, you don't have to know what's the smallest millivolt you're measuring, but it's enough to say we know it down to 1 volt. So for smaller voltages, you're having more precision and more decimal points. So let's take some real measurements. I want to show you how to use multimeter, and this is practical guide. Most of multimeters have 3 or 4 inputs, and shown inputs are common. That's where you put a black probe, and other 3 inputs depend on what you're measuring. 20A is for large currents, A is for small currents, and volt and ohm is for measuring voltage and resistance. When you start to measure, first put this black probe in COM position, and you won't move it for any other measurement. That is the common probe and all voltages are referenced to it, so you can call it ground or 0 volts. For measuring DC voltages, put other probe into most right position. Click the power on, and you can measure it, the DC voltages. If you know what voltage you're going to measure, put your range one higher. If not, start from the 1000 volts. You have to remember, never ever change the function while measuring. So, if I'm going to measure some voltage and decide, okay, I will then measure some resistance, don't leave your probes in the voltage or you burn something, multimeter or that device that you are measuring. So, always lift one probe when you change functions. You can change voltage ranges during the measurement, so from 1000 to 200 to 20, but you can't change from voltage to current to resistance, etc. So you have to think what you're doing, not going too fast. You have to remember how to measure voltage. Voltage is always measured, as I say to my students, like this. Always remember, when you're measuring voltage, always put your arms in front of you so you can connect parallel to the source that you are measuring. I'll tell you why that's important. Because in other measurements, like current and ohms, you can make some big mistakes if you are going to measure in parallel. So, if I have a battery, put one black one on the minus, red on plus, and measure. You can get also negative voltages, that's okay, and if you reverse the probes, you can also get negative voltages, and that's not a problem. You'll get just minus in front of your readout. And this is typical way to measure some voltage source. We have about 12 volts. And remember, always in parallel when measuring voltage. Yep. It helps in some cases. I don't know which, but next, something you may know is classic PSU, power supply unit for your computer, and I measured some voltages, some DC voltages, and on the left are declared voltages, and on the right what's measured with this multimeter. So, 12 volts, you get 11.68, and for 5.09, and that's okay. It's all under some tolerances, but that's okay. But take a look at that last one, 5 volts for USB, and you get 4.92, and you expect exactly 5 volts. Nothing can be exactly like stated. Why? Because USB, as all other voltages, have tolerances, and for tolerance for USB voltage is 5%. So if you measure somewhere between 4.75 to 5.25 volts, it's okay. So your USB don't have to be exactly 5 volts. And my students usually say the 5 volt at USB is the most precise source of voltage ever devised by human race, and that's not very true. So let's change to measuring DC current. When measuring DC current, you have to make a break in circuit that you are measuring. You can't just measure in parallel like voltage. You have to make a break, and what's easy to remember, always put your hands in a T. Why? Measure like this, not like this. So, plus goes to one side, minus to other side of a break, and current must pass through it. This is schematic representation. See that there's a break between lamp and battery, and that's how you measure current. You can't just put your probes parallel to battery or lamp, or you'll fry something. So to get a positive readout, you have to put a red probe to a positive source of current, and black probe where it goes. So current must go to red and exit to black, otherwise you'll get negative readout. That's okay also. And this is again our poor old battery, now with one resistor, and we are measuring 9 volts. What's the current through our resistor when powered with 9 volts? We have this little resistor, and we are measuring in series, not parallel. And we get about 10 milliamps. So our resistance is somewhere around 800 ohms. It's important to know how to start measuring amps or current. If you don't know the magnitude of the current you're going to measure, always start from the largest, and that's 20 amps. See, there are both DC and AC ranges of 20 amps. You measure large currents with it, but remember, they don't have electrical fuse in it, and it's very dangerous if you don't know what you're doing. Check the current with these high ranges. If your current is less than 200 milliamps, so you're measuring this in this configuration, check the current. If the current is less than 200 milliamps, you can change it to this configuration. In this configuration, you are measuring more precisely, but only currents up to 200 milliamps. This input has electrical fuse of 200 milliamps, so if it gets burned, you can change it. Here you can see on the left side, here's the typical electrical fuse on the cheap multimeter, cheap Chinese multimeter, and it looks cheap. And on the right, you see it looks more expensive, and it is more expensive. There are much more protective devices on high-end multimeters, but this on the right costs about, I don't know, 200 or 300 times more than this on the left. But anyway, if you fry something, you can change this fuse. So remember, if you're not sure what current you are going to measure, always start with the highest range and then go to the smaller one. If you are going to measure resistance, how to remember how to measure resistance? It's not parallel, it's not in series, it's always on your chest. Why? Always measure just a resistor, not a resistor in some circuit, because resistors in circuits can't be measured very accurately because other devices around it affect its resistance. Also, resistor must be unpowered. And the most prevalent source of damage to the multimeters is frying the multimeter when measuring resistance when the device is powered up or the resistor has power on it. So only measure resistors that are not powered. How this thing works? Well, in essence, every multimeter is just a voltmeter, and everything else is converted from resistance, current, AC voltage to DC voltage, and then measured. How you measure these resistors? In current in ohm meter mode, multimeter produces some small current at the ends of probes, like 1 milliamp or 10 milliamps, and it's fixed current. It passes through unknown resistor, and you are actually measuring voltage on that resistor. This current can't hurt you, but you have to know what's going on. That's what I also said. Measuring ohms is same as measuring DC voltage, just change position of range dial. You have 6 ranges. So you can measure very wide range of resistances. 200 means you can measure up to 200 ohms. 20 M means you can measure 20 mega ohms. Can you measure 200 ohms on that largest range? Well, yes, but it won't be shown on your meter. So always measure values, resistors, voltages, current, nearest the end of a range. So if we have, say, 18 kilo ohm resistor, we are going to measure it at 20K range. And I showed here what changes at all these 6 ranges. Why is number 1 on this multimeter and it's measuring nothing? Well, it does measure. It measures resistance between these 2 probes. Resistance between 2 probes now is infinite. And infinite is very large. And I told you that 1 means over range. So he can't measure infinite. You can see that decimal point is changing its place depending on what range you are going to measure. Also, it doesn't matter the orientation of probes when measuring resistance, but what is important. You can take resistor, measure it, and this is the usual way how to measure resistor. Put your fingers on there. You can't hurt yourself, but your body resistance will go in parallel to the resistor. When measuring small resistances like 100 ohms, 1K, it won't affect readout. But for larger resistors like 2 or 20 mega ohms, your resistance, body resistance is around 1, 2, or 5 mega ohms, and you'll get error in the measurement. Also, there's a small print there. Resistors are very changing are changing with temperature, and their resistance can change even if you just take it with your hand. And you can measure it and you'll see how the resistance is going up or down depending on the type of the resistor, but that's not very important to you, but here's just so you can know that. And here I'm measuring that resistor that was connected to that battery, and it's around 800 ohms. So remember, measure it like this, never in the circuit, especially when it's powered. Now we are going to change to AC current and voltage, but remember, measuring AC is very dangerous. If you don't know what you're doing, don't. You can get killed with wrongly measuring AC mains or something like that, so be very careful. Here's very short and brief preview of what's going on when measuring AC voltages. DC is easy. DC don't change over time. AC changes, and this is typical sine wave that changes through time. Measuring it, for some reason it's shifted. Measuring sine wave is like DC, you can't do that. Why? Because in DC you are measuring average or mean value. And mean value of symmetrical sine wave is 0, because you get same amount above and same amount below 0 reference. So in the sum, you get what's the mean value of sine wave, it's 0. So you can't measure it like that. You're measuring something called RMS, or root mean square. That's all you have to know. So it's a bit different than DC. This measurement is usually done just for a sine wave. Most of the cheaper multimeters can measure correctly just sine wave currents and voltages. Any other voltage, any other wave shape will get some error when measured, because your multimeter don't know what's the wave shape of the measured voltage. For that you need oscilloscope. And here's a representation of some standard wave shapes. For sine wave of amplitude of 1 volt, you will get a readout of 0.707, and that's okay. You don't have a readout of amplitude on your multimeters. Multimeters always show RMS, root mean square. So if I change to square wave, calculated RMS is also 1 volt, don't ask why, but this is going to measure 1.1111. There's a 11% error. That's not too much if you are not very picky, but it's an error. For triangle and sawtooth waves, you get also some small error. It might be critical, might not, depends what you're measuring. But I just want to tell you that you get some errors depending on what you're going to measure.
This applies only to this category?
Yes, and I'm going to answer your question with this next point. True RMS multimeters, and that means more expensive, can measure any type of wave shape correctly. Also, and that's all you need to know, modern auto-ranging several $100 priced multimeters can measure through RMS. Again, I say it may be useful to you, maybe not, depends what you're going to do. Also, source of an error can be DC voltage applied to AC. Here you can see that sine wave is not symmetrical anymore. It's shifted for the offset of DC voltage. And these regular multimeters can't correctly measure it, but through RMS multimeters can. I'm just showing this stuff on you so you can be informed about it. So, finally, we are measuring AC, standard configuration of black and red probes. You have 5 ranges of voltage, AC voltage, and be careful, you can measure only up to 750 volts safely with this specific voltmeter. Some say it's 600, some 1000, depends on multimeter. And here's measuring AC mains. And you may presume you'll measure 220 volts. Well, that's not true. It was up until 15 years ago, but today 230 volts is something you're expecting for your main outlet. And we have about 4 volts more than needed. And I just connected parallel to mains. Be very careful when doing this, especially with cheaper multimeters that are prone to breakage of probes, and you don't want to touch any metal during this kind of measurements. For AC currents, again, start from the highest range, test it for 20 amps. If it's less than 200 milliamps, you can switch to lower range. Again, current as small as 50 milliamps can kill you if it goes straight to your heart. So be very careful when measuring. Continuity. Well, that's popular with some people, and it does this. Actually, this is resistance measuring, and it measures if the resistance is less than 50 or 20 ohms, and that's considered short circuit. So if you are checking if ends of these two things are not connected, but it's not very conducting. But if I connect this, I get a beep. Beep means you have a short circuit. But short circuit is not 0. It's anything below 50 or 20 ohms, depending on a voltmeter. You can trace when do you use it. If you have a connector with, I don't know, 3 ends, you have to check which is broken, so you can connect one probe to one end, other probe to other end, and check every pin. And if some pin is in breakage, you can find what's wrong with it. This is maybe too much for you, but let's skip it. One thing is important to remember. Never measure continuity when the device is powered. Always switch off the voltage to because it's the same thing as measuring resistors. You can fry your multimeter if it's powered. So if you're measuring something in your power supply unit, switch it off first. and I measured this piece of wire, and it showed it's 0 millivolts, so it means it's about 0 ohms, and that's okay because short piece of wire has very small resistance. It's not 0 actually, it's somewhere about several milliohms, but that's very hard to measure. Diodes. If you know what diode is, it's an electrical component that passes current from one to other side only if correctly polarized. If reversed, if polarization is reversed, it's cutting off the current. Several types of diodes can be tested, and here's a list of silicon, germanium, Schottky, and if you don't know what those are, doesn't matter. Diodes have a voltage drop on them when they are passing the current, and that voltage drop is dependent on what type of diode is. You can test LEDs, but not all LEDs can be tested with this plain multimeter. Some modern, like white LEDs, need some special multimeters that can test such things. So you have to switch to that leftmost position to test diodes. It's the same position as a continuity test. Probes are same as for voltage measurement, and this is a diode how it looks in schematics. If positive voltage is on the right anode and negative on the cathode, it's a state when the diode is passing the current. If you reverse the polarity, the diode will cut off and won't pass any current. And here's the representation. You see, anode is on the positive side and cathode is on negative side. It's passing the current, and we are measuring voltage drop on it. It's about 0.5 volts, and that's okay. So this diode is okay. If I reverse now the diode, it will show overrange, so it can't pass any current, and that means that's okay. If something is shown in this state, that means that diode is broken. You can measure transistors in this way, because transistor can be shown as two diodes connected, and this is what I mean. NPN and PNP bipolar transistors can be tested like diodes, and so for NPN, if I put positive end on base and negative on collector, I'll get a readout of passing diode. If I changed negative to emitter, then again it will pass the current. If I reverse it, put negative on base and positive on collector, it should read not passing current. And in this way you can test any bipolar transistor if it's working. Most of the cheap multimeters have transistor HFE or beta or gain measuring, and that's this little slot here with several pins in it, pin slots. That's not very useful for most of you, because only some very specific analog designs need determination of a gain factor of a transistor. How it's used? Well, you have first to know pin out of a transistor emitter base and collector. Put transistor in PNP or NPN slot. Put emitter to A, base to B, collector to C. You see that slot for transistor. Change the dial to HFE. There's a small transistor in it, and it reads 168. That's the amplification factor of this transistor. And anything between 150 and 800 means that transistor is okay. And to most of you, it won't mean anything other than that that's not burned transistor, that it's actually working okay. Frequency. Frequency is a useful thing to measure. You have a relatively small range of measuring frequencies up to 200 kilohertz on this multimeter. Some high-end can measure up to 2 megahertz. But oscilloscope is much better tool to measure these things, but it can be still very useful. So put probes like in for measuring voltage, change dial to 20 or 200 kilohertz. Of course, if you are measuring up to 20 kilohertz, you'll get more precise, more decimal points than on 200 kilohertz range. And you can see that you can't measure very low frequencies with it. And here's a generator of 5 kilohertz signal, and I'm measuring 5.07. The source is 5.02. That's about 5% error, and that's okay. Measuring frequencies is not very accurate with this small, cheaper multimeters, but still can be useful. You have to check specifications of every multimeter. What's the maximum voltage and what's the minimum voltage that you can measure. You can measure up to 200 kilohertz, but you must think what's the amplitude of that signal that I'm measuring. You can't measure 1000-volt signal. That would be bad. Measuring capacitance. Also, this is not very spectacular. You have special meters like LCR meters for measuring capacitance, but it's useful for most of the applications. But errors are quite large and can be up to 10%. When measuring capacitance, you don't need probes. There are 2 slots in this multimeter, and there's where you put pins of your condenser. Switch it to capacitance range that you're wanting to measure, and here's a small 10 nanofarad capacitor being measured, and it says 10.2 nanofarads, and that's okay, it's under specifications. If I'm going to measure some larger capacitor, like 1 microfarad, I'll switch it to next larger range of 20 microfarads. Modern multimeters nowadays are auto-ranging. They're more expensive and easier to use. What's changed? You still have this dial, but you don't have to change from ranges under one function. You just select what you're going to measure. in this case, DC voltage on this battery, and it will show 9.39 volts without you changing the ranges from 1000 volts to 200 to 20 or so. It automatically does that for you. But observe, the result is same as this 25 or 6 years old multimeter. This also showed 9.39 volts. So, and this one costs about $800. So that's.
Not on AC measurements.
What?
Not on AC measurement, only the same.
On AC, no. But most of the time you're going to measure DC. If you're going to measure AC most of the time, then you need oscilloscope or something more bigger. But still. And there are these are some examples of outranging multimeters. They have a bunch of other functions you don't have to know about right now. So you just change the function and all other arranging is done automatically. But if you know to use this manual arranging, this will be a breeze to learn. Few things about accuracy and precision. Most people think that accuracy is the same thing as precision, but no. If you're measuring something accurately and precisely, it means you're hitting just the bullseye. Something can be very precise, but can be inaccurate. What that means? Precise means grouping around one exact value. And that means that the error is always the same. If I'm going to measure 1 volt and get 1.1 every time, that's not accurate, but is precise. Also, I can measure accurately, but imprecise. Accurately means that you're measuring around the correct value. But the error is not always the same. So I'm measuring 1 volt and I get 1.01, 1.02, 1.03. So the error is changing, but but it's still accurate. And last example is something is imprecise and inaccurate. So the values are all over the range when measuring. Why is that important? Because when you're reading data sheet for multimeter when buying one, you get something like this specification, number of percentage of reading on B range plus C digits. What that means? Well, this multimeter, its data sheet says it has an error 0.3% plus 2 digits, accuracy for all DC ranges. That means if I'm going to measure 15 volts, maximal error, it's not always the maximal. That's the worst case. You get 0.3% maximal error, and that's 45 millivolts. And two digits accuracy, or 1 digit, means that it should say +1, not +2. Okay, but okay. One last digit on 20 volts range is 10 millivolts. So in total, the worst case error is 55 millivolts. If I'm going, and that means that if I'm going to measure on this multimeter 15 volts, the real value is somewhere between these values. That means an error. No measuring device can measure without some error. And you always have to know what that error is. More expensive have less error, and etc. If I'm going to measure 15 volts at 200 volts range, I'll get much higher error, and that's 145 millivolts. So that's why you always have to measure at the right range. 15 volts measure at 220 volt range, not 200 or 1000, to get most accurate readout. Also, you can get 3.5 digit multimeters, but this one has 0.3%. Cheap Chinese multimeters have much higher error, but still same number of digits, 3.5, and that's what's changed in price. Let's say you're buying some cheap but very nice looking multimeter that says it has 4.5 digits, so it can display 199999, 0.5% error. 0.5% at 2 volt range means 10 millivolts, and that means that the last 2 digits that you're going to have your readout on your multimeter are just pure fiction. They mean nothing. So be careful when buying stuff like this. This is just a little schematic to show what's going with ranging. Ranging is, as I said, inside this device is a small digital multimeter that measures to some specific voltage up to 200 millivolts. So any other voltage must be scaled down so it can measure such small voltage. So you see, if I'm measuring voltages up to 200 millivolts, it goes directly to your chip. If I'm going to measure 2 volts, first I have to divide it by 10 and measure it. If I divide the voltages up to 2 volts by 10, I get 200 millivolts, etc. High voltages have 10,000 scale down factor. The most accurate readout is at that basic range. Any other measurement like resistance, AC, capacitance need to have conversion from that value to DC, and introduces some error. So you get idea that any other measurement than DC, you'll get some more error than that stated 0.3%. For say 20 AC current range, you get 3% error, and that's large. This means that something that may affect your measurements. This one has 10 mega ohm input resistance. That's what is seen by a source that you are measuring. Cheaper multimeters have lower resistance, and it can affect your measurement. Here's how. You get a voltage divider. You're actually lowering the voltage that you are measuring. If you have high input resistance, that error is very, very small. Analog multimeters have smaller input resistance and introduce much larger error, for instance. Safety. Cheap multimeters like those cheap Chinese can get easily broken. and these probes are very poor quality, and it can be damaged, and that's not very safe when you are measuring AC voltages. So, and if you are going to do something wrong with it, it will most surely explode or just malfunction. More expensive multimeters have a variety of safety measures built in, so that's something you have to think about. These are some typical cheap multimeters. Observe, we had at the start very expensive Fluke multimeter, and this is cheap Chinese Fluke. And you see that there's a Fluke, original Fluke, on the left side. Analog multimeters, those are the things with scale. It's electromechanical device, and it's somewhat more hard to use for novice. Here's measuring 9-volt battery. Ranges are the same, almost the same as at a digital multimeter, but what you have to know is to read this scale. And you'll see a bunch of numbers here. First, you decide what you're going to measure. You have a separate scale for voltage and current, and depending on what range you are going to measure, you see you have ranges 1,500, 250, and etc. And you look at what value you're going to read out. So if you are going to measure 500 volts, 50 is the number of these marks that's very useful. So when needle shows 50 marks, that means 500 volts if you are measuring at 500 volts range. So you just scale that number of marks to that voltage or any value that you're measuring. AC has separate scale, red one. And resistance is another separate scale, and it goes in reverse. On the left, it's not zero, it's rather infinity, and on the far right, it's 0 ohms. That's because you're measuring actually current. Device passes current through a resistor, and current is 0 when you are measuring very large infinite resistor, and because that it's on the left. When you are measuring maximum current, resistance is then considered very low or 0. That's because it's on the right side. One of the specifics for measuring resistance with analog is that before any measurement you have to short probes, and there's a small potentiometer on the side or on top of a multimeter, and you see here it's not exactly 0. You have to move this needle to show 0, and then you'll have with this regulation, and only then you'll get accurate readout. Everything other is the same. There's also a mirror on some old analog multimeters. It's useful to get more precise readout. You have to look at the mirror from above, and reflection in mirror must be overlapped with the needle, and then you are looking at just a right angle. Why are analog multimeters useful? Well, they have low input resistance, and that's useful when measuring some lines with parasitic induction. Doesn't matter. But what is interesting, most of the analog multimeters can measure voltage and current without any batteries. That's because a small amount of current is being stolen from the value that you are measuring, and needle is moving by this small current. Only when you are measuring resistance, you have to put some batteries in it, so it will be a source for current that makes voltage drop on the resistor. And that's it.